Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X published on October 21, 2025, about 3 days ago. This paper makes native high-resolution video generation practical, hitting 2.69 times faster inference at 1080p and 4.78 times at 4K while demonstrating the first native 4K synthesis. The paper is titled UltraGen, high-resolution video generation with hierarchical attention, and as we'll see later, the results are really impressive. Beyond speed, it pairs a spatially compressed global attention path with a cross-window local attention path and time-aware fusion, outperforming two-stage super-resolution pipelines and prior state-of-the-art models in fidelity and temporal consistency. Alright, the previous segments set the goal. Figure 1 contrasts runtimes and visual quality from 480p to 4K across WAN, HUNUAN video, and UltraGeneral. The top row shows WAN across resolutions. The middle row shows HUNUAN video. The bottom row presents UltraGen, which keeps crisp detail beyond 2K and finishes 4K in under 2 hours, delivering about 4.8 times speed up versus WAN, while the baselines blur and their time balloons from minutes to many hours. So the previous figure compared outcomes. Figure 2 shows how the system achieves them. The middle panel illustrates the global local mechanism that fuses a compressed global path with a windowed local path using a time-aware weight alpha of t, so early steps favor structure and later steps sharpen details. The left panel compresses, attends, and decompresses to maintain long-range semantics. The right panel partitions frames into windows and shifted windows, which keeps compute near linear while preserving cross-window coherence. Alright, the previous figure summarized the architecture. Table 1 presents head-to-head quantitative comparisons across 1080p and 4K. At 1080p, the model attains the lowest HDFVD at about 214, with the best HDMSE near 390 and the highest HDLPIPS around 0.546, plus top temporal consistency near 0.983. For 4K, scores remain best or tied best, with HDFVD about 425, HDLPIPS roughly 0.645, and temporal consistency near 0.971. The star notes best among non-super resolution methods. Okay, Table 1 quantified the gains. Figure 4 presents qualitative comparisons across multiple prompts. The left half shows 1080p comparisons, where WAN and HUNUAN video often blur or miss semantics, and super resolution variants only sharpen noise. The right half shows 4K scenes, where artifacts and smeared textures persist for baselines. Red boxes indicate zoomed regions, and the bottom row retains crisp textures, stable edges, and accurate prompt details, which signals better temporal and spatial fidelity. So the previous figure highlighted visual quality. Table 2 reports the runtime gap that makes this practical. At 1080p, UltraGen finishes in 13 minutes, compared with WAN at 35 minutes and HUNUAN video at 43 minutes, which yields about 2.69 times speed up. At 4K, UltraGen takes 1H 50 minutes versus WAN at 8H 46 minutes and HUNUAN video at 11H 36 minutes, giving roughly 4.78 times speed up. These gains matter because faster native high-resolution synthesis enables broader use without a two-stage pipeline. So the previous table covered runtime. Table 3 evaluates quality with vBench, listing subject consistency, background consistency, motion smoothness, aesthetic quality, imaging quality, and the average. At 1080p, the method leads with the highest average near 0.854, helped by strong imaging quality and competitive motion smoothness. At 4K, the method again tops the average at about 0.846, which indicates balanced gains without sacrificing temporal stability. The SR column marks which systems rely on super resolution, clarifying that the strongest averages come from native high-resolution synthesis. Alright, 2 takeaways stand out. The dual-branch design, with spatially compressed global attention plus cross-window local attention and time-aware fusion, makes native 1080p to 4K practical, and it delivers both faster inference and better fidelity than super-resolution pipelines. The broader implication is clear. Scalable, end-to-end high-resolution video generation becomes a usable building block for creative tools and production workflows. Thanks for listening. That is it for this episode of the AI Research Roundup. I am Alex.